Now I have this part open in your book because I want to explain to you where this very important key concept and this general equation, where it comes from. I want you to understand exactly where it comes from and what it means. Okay? I want you to look at this. When we're talking about, we're kind of trying to generalize these arithmetic sequences so we can do some manipulation with them. So here is the first term. We're going to call it A1, first term. And that's what the first term would look like in terms of A and D. D is the difference, the common difference. So in numbers, it might look like this, an 8. Okay, our next term, A2, our second term, would be A plus whatever the difference is. Okay, so we basically are adding A plus 8 plus 3, which is 11. Our third term is A1 plus 2 times the difference. Think about it. Because to get from 11 to 14, we have to add 3. To get from 8 to 14, we're adding 6. So we're adding 2 times 3. For the fourth term, we've got A1 plus 3 times the difference. To get to 17, which you can tell with the pattern, 8, we're adding 3, adding 3, adding 3. If you add 3 times the difference, you get to the first term, you get 17. So what they've done is they've generalized this pattern. So you can see, what do you see in common between this number here and this number here? This number's 4, this number's 3, this number's 3, this number's 2, this number's 2, this number's 1. Okay, so this number here is always 1 less than whatever term you're on. So that's how they're generalizing it. This number here, 3, is 1 less than the term you're on, and you multiply by d, okay? And this is the equation. So the nth term of the arithmetic sequence, the nth term can be the 100th term, the 1000th term, the 10th term, it doesn't matter. The nth term equals the first term plus n minus 1, so whatever your term you're on, minus 1 times the difference. That's how you're going to find that. So let me put it into an example and hopefully it'll make more sense. So we're going to keep this equation right here to help us. Write an equation for the nth term of the following sequence. Then use the formula to find the 26th term. So if I wanted to know the 26th term, instead of adding 4, adding 4, adding 4, adding 4, adding 4 until for 26 times, I can figure it out by using an equation like this. So let's break this down. A sub 1, that is my first term, okay? Which is 4. Okay, 4 is my first term. N minus 1 is my next section. Now D is the difference, the common difference. So what is the common difference? We're adding 4 each time. Okay, so D is 4. Okay, so what this says, I'm going to just simplify it. A sub n equals 4 plus, I'm going to put the 4 in front because it just looks a little bit better. Like this. This is the general equation. So if I want to know what the 26th term is, so I want to know what my 26th term is, all I have to do is plug in 26 for n and solve this simple equation. Okay? 4 plus 4 times, that's 25, okay, equals 4 plus 100 equals 104. So if I kept going, 24, 28, 32, blah, blah, kept going, when I got to term 26, my term 26 would be 104. Now I want you to give it a try. Okay, I want you to try to figure out, this black, if you have this sequence, 10, 8, 6, 4, 2, and so on, what would the 31st term be? Okay, so you have to come up with the equation for the nth term of an arithmetic sequence that looks like this. And then you can plug in 31 for n and get the 31st term. You try. Okay, so let's break this down. A sub n equals A sub 1, that's the first term, 10, plus n minus 1 times d, you got to know the difference, we're subtracting by 2 every time, or adding -2. So -2 is my difference. So I'm going to put a -2 here, okay? So I'm going to rewrite this just to make it a little bit neater. 10 plus, I'm going to put the -2 in front, n minus 1, okay? Now, n is 31. I want to know what the 31st term is. A sub 31 equals 10 plus -2 times 31 minus 1, okay, equals 10, 10 plus, sorry, a -2, sorry, this is not working, times 30, okay, equals 10 plus a -60, which happens to be -50. Okay, so if I kept going -2, -4, -6, -8, blah, blah, by the time I got to the 31st term, -50 would be my term. That's all there is to it.